Hey guys, this is Dr. Kruse, Elementary Statistics. We're going to go over some basic terminology for statistics. Now, the first thing we'll discuss is the word population. Population is every member of some group. It's just whatever group you're looking at. Maybe we're looking at all NOC students on all three campuses. So maybe if you put all the students from Stillwater, Enid, and Tonkawa, all three campuses, if we put them all together in one group, we could call that population. And then maybe we'd measure something about a subset of that population. It just depends how big a group you want to measure. For example, our population could be the United States of America, all right? And maybe we just want to measure Oklahomans. Out of all 50 states, we just want to measure Oklahomans. So the population is every member of some group, no matter how big you make that group. And individuals are just members of that population, members of that group, members of the population of interest. So if we were talking about all three campuses again, maybe we'd be talking about, individual students within that group, within that population. Now, a variable, you can see the word vary right there. V-A-R-Y is almost right there. Vary, it's something that varies, something about the individual, these guys, something about the individual that we want to measure, all right? Something that varies or differs from individual to individual. So for example, if we were talking about these students from the population of all three campuses, maybe I want to know the average height of a NOC student, or the average weight, or the average eye color, or the average gender. What percent are female, what percent are male. It's just anything that varies from person to person that you want to measure. Okay, next, as we're looking at these variables, we can break these variables down into quantitative variables and qualitative variables, two different types of variables. Now, quantitative, you can see the word quantity in there. Basically, it's something that you can apply some kind of math to, all right? Something you can do. You can add them up, you can average them, stuff like that. You can do math with it. So it's anything that can be added, averaged, counted, measured, etc. So anything that you can put a measurement to or perform a calculation with. So maybe you want to do average weight. You add up all the people's weight in the room and divide by how many people there are, and you have their average weight. You averaged them. Same thing with height. Add up all the heights, divide by 27 or however many is in the room, and you have your average height. Dollars in a wallet, okay, maybe I have $5, maybe you have $7, maybe the next person has $20. We add all those up and divide by 3, and now we have an average dollars in wallet, number of dollars in wallet. Those are quantitative variables. Maybe number of siblings. I have 4 siblings. Maybe you have 0. Maybe the next person has 2. We add all those up and divide by how many measurements we took, and we have an average. So anything that you can apply math to, anything that you can measure, anything that is a quantity, a certain number of, we call a quantitative variable. You can apply some kind of math to it. Whereas qualitative is, you can see the word quality right there. It's a quality that allows you to separate it into categories, all right? These are not numerical. You can't really do math with them. So it's something like gender, are you male or are you female? All right, maybe we put the males in one corner of the room and the females in another corner, so we can separate you into categories, but we can't really do any math. We can't do any averaging or anything like that. All we can do is basically separate you into categories. Same thing with eye color. Maybe put the blue-eyed people in one corner and the brown-eyed people in another corner and so on. I could separate you into corners. I could put you into categories, but I can't really do any math with it. Voting preference, Democrat, Republican, Independent. I could put you guys in 3 different corners of the room in 3 different groups, but that's all I could do is just categorize you. I can't really apply math to it or run an average or measure you in any way. Hair color, put the brown-haired people in one color corner, the black-haired people in another color, the redheads in another color, in another corner. I kept saying color. But anyway, separate you by hair color into groups, all right? I might have 3 or 4 or 5 groups, but that's all I can do. I can't do any math with it. Same thing with the fraternities, all right? Separate you by fraternity, and I'll have, 8 or 10 different groups, but I can't do any math. And same thing with tribes. Different tribes, I can separate you out, but that's a variable. People vary from tribe to tribe, One person might be Pawnee, one person might be Osage, one person might be Kaw, but I can't do any math with it. All I can do is separate you or put you in categories according to a quality that you have, all right? Not numerical. Okay, now back to population, and we're going to compare it to sample. Now, this is not individual. Remember, an individual, if we were talking about everybody in Oklahoma, let's say that the state of Oklahoma is our population, everybody in Oklahoma. Well, the individual is every single person in this group here. But if we take a sample from this population, what we're doing is taking a subset of these individuals, all right? All those people in Oklahoma, all those individuals, if we take a group of them, not the whole population, but we just take a group of them, a subset of the population, well, maybe that would be just the people in Stillwater, all right? So maybe our population, maybe we send a survey out and we want to find out something about everybody in Oklahoma. We want to measure something about the population, but we don't have time to, visit with everybody in Oklahoma. So maybe what we do is instead we pick a sample, the people in Stillwater, and we send the survey just to them, just to the people in Stillwater, all right? So if you can't reach everybody in the population, and very rarely can we reach everybody in the population, what we do instead is we pull out a sample, a subset, and then we just send the measurement to them. We measure that subset. Some more examples are, like we talked about, all NOC students at all 3 campuses, but maybe our sample would be just the people in this class, all right? Maybe I want to know the average height of an NOC student, but I don't have time to go to Stillwater and Tonkawa and Enid. I don't have time to go visit the entire population and measure everybody's height. But I do have time to measure this class, all right? That would be my sample. That's a subset of everybody at NOC, all the individuals in the population. A subset of that would be the people in my class, all right? They're handy. I can measure them. I can add up all those heights, and I can divide by 30 or 20 or however many's in that class. Maybe the population is all Black Angus cows. It's a certain breed of cow, all right? Maybe all Black Angus cows in the nation, in the United States, or maybe in the world, all right? But I don't have time to go, measure, let's say, the average weight of a Black Angus cow. I don't have time to go out and measure every Black Angus cow in the world. So instead, what I do is I take a sample, I take a subset, a small group from the population, and I measure that one. So maybe the ones in my pasture are convenient. I can weigh all them, add them up, and divide by how many cows I have. Another example is all Oklahoma foxes. Maybe that's my population. Maybe Oklahoma State University is doing an experiment on foxes. They're observing something about foxes. But you know what? If they want to measure the average weight or the average height or the average number of teeth they have or whatever they're measuring, it's impossible, almost every time, it's impossible to catch the population, to catch all the foxes in Oklahoma. So what we do is we just take a sample, a subset, and maybe it's just the 30 that we could trap, the 30 that we could catch, all right? We'll call that our sample. No, we didn't measure every fox in the population, but we measured the 30 that we could catch. We measured a subset, a sample of the population. And I think this is my last example here is, NOC Stillwater students. Again, maybe that's my population. Maybe it's not all 3 campuses. Maybe it's just the ones in Stillwater. So maybe I want to measure, I wonder, what percentage of Stillwater NOC students are left-handed. You can measure whatever you want to measure. And I don't have time to go check every single Stillwater NOC student. There's a couple thousand of them. So what I do instead is I just grab a nice convenient sample, all right? I grab a subset, maybe this class. I'll say, hey, raise your hand if you're left-handed, and I'll count how many left-handers there are. We'll turn that into a percentage. So it's easy to do if you take a subset or a sample of the population. If you don't have time to catch all the foxes or you don't have time to measure all the students, well, then catch the ones you can catch and measure that. And we apply this, it's not going to be exact, but we apply this information from the sample to our population. It'll be pretty darn close as long as we pick a pretty sizable group. In statistics, usually the magic number is 30. As long as you grabbed 30 in your sample, the measurement that you come up with in your sample will be really, really close to the measurement in the population, the actual measurement. Okay, and a couple terms I don't use very much are population parameter and sample statistic. Again, this deals with population. Parameter means meter, that's a measurement. You know, like a meter stick, you're measuring something. That's a measurement describing population data, all right? It never changes. So whatever the average, let's go back to the Black Angus cows. Whatever the average weight of Black Angus cows, all the Black Angus cows in the world, whatever that is one certain number, all right? I would add up the weight of all those cows and divide by how many cows that was, and that's going to come up with a precise certain number. That data will not change, all right? It's out there. We'll never be able to find it because we're never going to be able to catch all those cows and weigh them and average that. It's just an idea. It's a theory. It's a philosophy. If we were able to catch every Black Angus cow in the population and average their weight, that would be the parameter, well, I would come up with one certain number, an average weight of, 1,100 pounds or whatever. It'd be very precise. It'd be one answer. But when you're grabbing samples just out of, what's convenient, a measurement describing sample data, so maybe I go measure, a herd in Stillwater, and I'll come up with, maybe 1,050 pounds is the average. And maybe I'll go measure a herd in Perry, all right? And maybe they're pretty well fed and their average is 1,150 pounds. Well, that data is going to change, all right? Your samples are going to be different from group to group to group. It just depends on which group of cows or foxes or people you're able to grab. So sample statistic is a measurement of that sample, and usually that's going to change from group to group. It's still going to be pretty close to whatever this mythical perfect number is that we'll never be able to calculate. Our sample data will be close to this, but it'll never actually be exact. It'll just be close. Sometimes it'll be a little high, sometimes it'll be a low, depending on what group we were able to catch and measure. All right, next I'm going to give you a little peek at levels of measurement, kind of from least precise measurement to most precise measurement. So starting with nominal, that's our least precise, and then ordinal and interval and ratio, all right? I'm actually going to start at the bottom. I'm going to start at the most precise level of measurement, kind of work my way backwards to the least precise. Okay, let's start with ratio. So this is the most precise level of measurement. Think about your speedometer in your car as you pull up to a stop sign and you're slowing down. You're 3 miles an hour, 2 miles an hour, 1 mile an hour, and then 0 miles per hour. And you don't go any slower than 0. You don't go to -1 miles per hour, -2 miles per hour. It doesn't go past 0. What we call that is a real 0. When things stop at 0 and they don't go into the negatives, then we call that a real 0. That 0 is real. Everything stops at 0. It means the absence of something. It means there's nothing else. There's no more. So 3 down to 2, down to 1, down to 0, and stop. If you can't, whatever you're measuring, if you can't go into negatives, then we call this 0 a real 0. And that's the defining characteristic of a ratio. Now there's other things that we're going to talk about. You can name your data, all right? This name is 3, this name is 2, this name is 1, this name is 0. So I can give everybody a name or a number. I can also put them in order from fastest to slowest or lowest to highest, all right? This is fastest speed, this is slowest speed, all right? So I put it in order from fastest, a little slower, and stopped. So I put it in order from fastest to slowest. If you can put it in order, that makes your measurement a little more precise. And if there's regular intervals between these things that you have named and ordered, so the difference between 3 and 2, that's 1 mile an hour. The difference between 2 and 1, that's 1 mile an hour. The difference between 1 and 0, that's 1. All right. If there are regular intervals in between each of these numbers, if the differences are the same, that's another measurement that makes this the most precise level of measurement. So you can name them 3, 2, 1, 0. You can put them in order from fastest to slowest, 3, 2, 1, 0. There's regular intervals. That's 1 apart, 1 apart, 1 apart, a difference of 1 no matter where we check. And 0 is a real thing. It's a real 0. Things stop at 0 and they don't go into the negative. So that's the ratio level of measurement. Now, if I back up one to the interval level of measurement, I'm going to lose number 4 here. I'm going to lose the concept of a real zero. So let's back up to interval, all right? And I want you to think about temperature, during a cold snap, and the temperature is dropping. It's 3 degrees, it's 2 degrees, it's 1 degree, it's 0 degrees. But think about temperature. It can be below 0. It can be 1 degree below 0, 2 degrees below 0, 3 degrees below 0. So notice the difference. Speedometer stops at 0. That's a real 0. But temperature doesn't stop at 0. It just keeps going. That's not a real 0. Everything else is the same, all right? I can name them. 3, 2, 1, 0, -1, -2, -3. I gave them all a name. I put them in order from high to low. I wrote lowest to highest, but they're from high to low. This is the highest temperature. This is the lowest temperature. They're still regular intervals. There's a difference of 1 degree. There's a difference of 1 degree. Everywhere I check, they're only 1 degree apart. Each interval is 1 degree. The only difference is there's no real 0. We also call it a natural 0. So there's not a natural 0. This is kind of like just another number, all right? 3, 2, 1, 0, -1. There was nothing special about 0. It's just another number, okay? Interval. Now, if I take away the intervals, what I have is ordinal. See the word ordinal almost right there? All right, so I'm going to take away the 0. I'm going to take away the regular intervals. And now all I have is things that are named and are able to be ordered from worst to best or fastest to slowest or lowest to highest. This is ordinal. That's the best I can do, is name them and put them in order. So I like to think of a foot race, all right? So maybe this person came in first, this person came in second, and this person came in third. Okay, I can name them. This person gets the first place medal. This person gets the second place. This person is third. So they each have a name, first, second, and third. I can put them in order from, fastest to slowest. This person finished first. They're the fastest. This person finished third. They're the slowest. So I can name them. I can put them in order. Now, the intervals between them are not the same. These guys, they might have finished maybe 1 second apart. Maybe it was a photo finish. It was really close. And then maybe this person came dragging in like 10 seconds later. So the interval between these two was 1 second, but the interval between these two might have been 10 seconds. So the intervals are not the same. There's no regular intervals, and 0 has no meaning here. So the best I can do here is give them a name and put them in order. So since order is the highest I can do, I call this ordinal. I can put them in order. And then the least precise is nominal. And you can almost see the word name right there. N-A-M-E. I think it's French for name. All I can do with this is just give them a name. I can't put them in order from worst to best, or lowest to highest, or fastest to slowest. There's no regular intervals in between them, and 0 doesn't mean anything. It's not a real 0. So for example, that's handing out jerseys to a team. Maybe this person got jersey number 2, and this person got jersey number 1. This person got jersey number 3, all right? I can't do anything with that, all right? I can't put them in order, all right? I can't say that, oh, this guy is much better than this guy because he's 1 and he's 3. No, these numbers have no meaning here, all right? Here they had meaning. First place was the fastest, third place was the slowest. Here, these numbers have no meaning. It doesn't mean that 2 is worse than 1. It doesn't mean that 2 is better than 3. They mean nothing. It's just like a name, all right? It's just like Fred, John, Harry, whatever. So all we can do in this case is give each one a name. I can't put them in order. There are no regular intervals between. 0 doesn't mean anything. One of these jersey numbers could have been 0, but it doesn't mean anything, all right? The only thing I can do is name them. And if that's all you can do, that's nominal. That's the least accurate level of measurement. Okay, so one more look from top to bottom, I'm putting them in order. So nominal, all you can do is give it a name. Ordinal, you can give it a name and put it in order. Interval, you can give it a name, put it in order, and the intervals are regular. The intervals are the same. There's the same distance between any two numbers. And then finally, ratio, you can give them a name, you can put them in order. The intervals between each one are the same. And 0 is a real thing. Everything stops at 0. Okay? All right, guys, that's it for today.